say find the measure of each missing side and angle. So just to recap, finding missing sides and finding missing angles uses tools from this course. Sometimes we use law of sines, sometimes we use law of cosines, and sometimes we just use SOHCAHTOA. 5, 6, and 7 are all going to be SOHCAHTOA problems because they all involve a 90-degree angle. SOHCAHTOA is a tool that we use for right triangles. We don't have to use a law of sines or law of cosines. So that's a good clue to let us know that SOHCAHTOA is going to be what we use to solve this problem. Let's take a look at number 5 and just go ahead and label some sides. If this is big B, we know this is little b. But more importantly, if we're going to use this 53-degree angle, little b is the opposite side. That's going to be a key term for SOHCAHTOA. If this is large A, then this is little a. But more importantly, once again, for that 53-degree angle, there's two included sides. There's the hypotenuse, which is our value of 5, and then there's the other side, which we call our adjacent side. So we have little b and little a, but most importantly, 53 degrees is our given angle. Then across the triangle, we have our opposite side, and next to that angle, we have our adjacent side. It's good to label these opposite and adjacent so we can pick the right tool. We want to think about what we know and what we want. In this case, we know the hypotenuse is 5, so that's our h value. This is either going to be SO or CA, because they're both using hypotenuse. The instructions say find both sides, so let's just decide the first thing that we want to find is our b value, our opposite side. So if we know hypotenuse and we want opposite, we want to start with SO, because it has both of those ingredients in it. So let's set up our equation. The sine of 53 degrees is equal to the opposite, which is little b, over the hypotenuse, which is 5. At this point, we can just solve for our unknown value. If it's b divided by 5, we can undo that by multiplying. And then all we have to do is multiply by 5 on the left side of the equation to keep it balanced. So whatever 5 times sine 53 is our b value. We make sure our calculator is set to degrees and go ahead and work that out. And what we get is 3.993 as our b value. So we found our missing side, it's 3.993. We're going to go ahead and find the adjacent side. So once again, we're going to take advantage of what we know. We know the hypotenuse is 5, so that's going to be SO or CA. And then we're looking for our adjacent. So this expression has what we know and what we want combined. So that lets us know cosine is the right function to use. So cosine 53 is a over 5, because we're using little a to label that side. Once again, we just want to multiply by 5 to solve for a, and we just multiply by 5 on the left to keep that operation balanced. And when you multiply this out, what we get is 3.009 as our a value. So we've answered the first part of the instructions, which is just use SOHCAHTOA to find the two missing sides. Whichever side you want helps you decide the equation to pick. The other part of the instruction said find the missing angle. So this is actually going to be really easy. We know the total is 180, and we know this is 90 and this is 53. So if we subtract 90, if we take 180, subtract 90, and subtract 53, we get the measure of this angle. This angle is a 37-degree angle right here. All right. So that's number 5. It's just using SOHCAHTOA. And actually 6 and 7 are going to use the exact same solution procedures. Let's go ahead and work through those now. So if we look at number 6, we know 24, and that means across the triangle, little a is opposite of the angle that we know. And if we know 24 and we look next door, then little b is next door, so little b is adjacent. And then 14, that longest side, that's always our hypotenuse. Right? Even though they both touch 24, automatically the long one's the hypotenuse, so the other angle is that adjacent angle. So the instructions still say find each missing side. Once again, let's do the opposite side first. So we want opposite and we know hypotenuse. So we're going to use so, because it's got what we want and what we know. Sine 24 equals a over 14. And then once again, that one step is just going to be get rid of division with multiplication. And make sure you do it on both sides to keep that equation balanced. When we multiply this expression out in our calculator, what we get for our a value is 5.694. Okay, let's do the adjacent. So if we want adjacent, it's either ka or toa. And since we know the hypotenuse, that narrows it down to using ka or cosine. So cosine 24 is b over 14, because we've labeled our adjacent side b. And then once again, we want to multiply to isolate b. And we just multiply on the left to keep that operation balanced. And what we get for b, when you multiply this out, is 12.790. And if we look at our picture, that makes sense, right? If this is 14, this seems to be a little bit shorter, so this number works. And this seems to be significantly shorter, maybe half as large, or maybe even a little less. So 5.6 is a value that makes sense for BC. And then let's do the angle, right? We got to do the angle for each problem. So we know the total should be 180. And we take away the 90-degree angle, and we take away the 24-degree angle. And what we get here for big B is it's a 66-degree angle. Okay. So 5 and 6 are SOHCAHTOA, and so is number 7. We know it's SOHCAHTOA because it's a right triangle, so we don't need to use law of cosines or law of sines. You can, it's just unnecessary, and you may even notice as you start to use law of sines or law of cosines that it ends up being the same type of calculation. And we can worry about that some other time. So once again, let's label. If this is big A, this is little a. But more importantly, for our 40-degree angle, it's across the triangle. It's the opposite side. And if this is big B, this is little b. But most importantly, since it's nearby or neighboring our 40-degree angle, we'll call it adjacent. And then our longest side, we will call hypotenuse. So let's do the opposite first. So we're going to be using sine. Sine of 40 is opposite over hypotenuse, a over 3. Multiply this and multiply to get our solution. And what we get for our a value, our first side, is 1.928. If we want to find b, which is our adjacent, we're going to use cosine, because cosine is adjacent over hypotenuse. We got to divide it by 3 to get rid of. Nothing new there. And so we multiply by 3 on the other side to get our value. Multiply by 3 to keep that equation balanced. And what we get for 3 cosine 40 is 2.298. So that's our b value. Smiley face. We're almost done. We still have to find this missing angle. So let's just bring the calculation over a little bit. We have 40 and 90. So for it to add up to 180, we do a little subtraction, minus 40, minus 90. And what we get for our big B is 50 degrees. Smiley face with ears. So that's 5, 6, and 7. They're all SOHCAHTOA. There's 2 things that make them SOHCAHTOA problems. First is the instructions say missing side and missing angle. And then because they're 90-degree angles, we don't have to use law of sines or cosines. We can just go back and use SOHCAHTOA that we've been using for a few weeks now. So that's 5, 6, and 7. To see the next couple of problems, be sure to click on the next video.